session, we will look at an important technique called online analytical processing, or OLAP in short. There are two important technologies that play a role in the implementation of OLAP: the data warehouse in the backend and business intelligence in the front end. I'm going to begin by talking about the data warehouse. Indeed, there is a lot of engaging discussion surrounding what a data warehouse is and how it is different from a regular database we use on a day-to-day basis for booking out tickets, placing orders in the stock market, and so on. A data warehouse is a subject-oriented, integrated, non-volatile and time-variant collection of data in support of management's decisions. I would now draw your attention to the four important keywords included in this definition and discuss each one in depth. Firstly, a data warehouse is subject-oriented in nature. What we mean is that the data warehouse includes the collection of data pertaining to a handful of well-defined subjects rather than including the whole gamut of information of the entire enterprise. Just look at it this way. We have assembled the data sets for investment analysis. We have collected information about the startup companies in the company's data file and information about investments made in the investments data file. Just for illustration, let us look at a couple of examples to see when you would not consider this to be a data warehouse. Suppose we collected all this information from an online portal like nascom.in, where startups can log in and upload their information applying for funding. If my dataset included all their application details, the biodata of all the employees, information about their past products, and so on, then clearly our data store contains information about many subjects. According to Bill Inmon, that is not a good thing for analysis. Instead, since we are interested in sector-wise and geo-wise analysis of our investments, we should include only data pertaining to these subjects in our data warehouse. Let us move on to the second keyword from the definition of the data warehouse. A data warehouse is an integrated repository. It is worth noting that information pertaining to a subject may actually be coming from many different systems. In our own case, there could be one portal where the startup application data is collected. There might be another database that contains industry standard sector information. There might be yet another database that contains information about investors themselves. So what we are saying is that when building a data warehouse, we must bring together all the information from these multiple sources into a single integrated data warehouse repository hosted in a single location. Moving on, the third keyword in the definition of data warehouse is that the data warehouse is non-volatile in nature. Volatility indicates changes. In the context of a data warehouse, what we want to say is that the data is a repository that will never change. This part of the definition gains enormous significance in the face of stringent compliance standards like the Sarbanes-Oxley or the SOX Act, as we call it, that have surfaced to prevent fraudulent activities. Needless to say, non-volatility also prevents data from being erased or deleted. The non-volatile nature of a data warehouse is important for giving legitimacy and credibility to the analysis being done on the data. In the context of our investment analysis, what we are saying is that we cannot keep modifying the figures of exact investment that have been made by a given investor. If that is allowed, our whole analysis will become questionable. That brings up the seemingly contradicting requirement that a data warehouse is time variant. Here, time variance is referring to the importance of historical data for analysis. The time variant nature of the data helps us build adaptive analytics that reflects newer understanding and inferences based on newer data. I would like to add that time variance does not contradict with non-volatility requirement. Non-volatility only prevents existing data from being changed without any legitimate reason. There is no problem with newer data being added to build historical information. Just think about it. In our investments data, we have an investor, DT Capital, who invested $2 million in 06.com. We are not allowed to fudge that number or change it. So that is non-volatility for you. On the other hand, if the same investor had invested in the same company or some other company sometime later, we are allowed to add that data to build the historical information about that investor. There you have it, the full definition of a data warehouse. We saw the 4 important keywords from the definition: subject orientation, integrated, non-volatility, and time.
You are looking at an enterprise view, you have to work with all the systems in the enterprise, right? So if I'm the CEO or I'm the CFO of the company and I need to look at my organization in its totality, then what will happen is I will have multiple systems talking to me. I will have the sales system talking to me. I'll have the HR system talking to me. I'll have, the marketing, the risk. All of them have their own systems and processes. Now, I don't get one view. And if I were to give out this task to somebody to create that one view, they would have to go and understand all these systems. They would have to understand the appropriate linkages between these systems, and they would have to then create that view. So all of this is solved by the